So hi and hello, welcome to our channel named Algo Exploration. My name is Sami and today we will going to learn how to find the answer of power of an element. So the input is two integers a and b. A should be greater than equals to 2 and b should be greater than equals to 1 and the output will be a raised to b. So we have to find a raised to b. So let's take a as 2 and b as 64. So at last we have to find the answer of a raised to 64. So what will be the approach? Since we are using divide and conquer technique, we have to divide it first. So let's say I am dividing 2 raised to 32 by 2 raised to 32. So this will be 2 raised to 32. The dividing structure will be b by 2. That will be 64 by 2, that is 32. Now after that, getting the answer from these terms, we will actually multiply it, and after multiplying we will return the answer to its parent function. Now let's go it further. This will be divided by 2 raised to 16 and 2 raised to 16. Similarly this also 2 raised to 16 and 2 raised to 16. This also 2 raised to 8, 2 raised to 8. So 2 raised to 8 is getting computed for almost 8 number of times. If we do this 2 raised to 4 and then 2 raised to 4, we can see that 2 raised to 4 is getting computed for almost 16 number of times. So why should we actually compute it again and again? We will actually compute it once only and then we will multiply it. That is, after getting the answer of this term, we will multiply it. Let's say the answer is y, then we will do y into y and we will return it to its parent function. So the tree will look like this: 2 raised to 64, 2 raised to 32, 2 raised to 16, 2 raised to 8, 2 raised to 4, 2 raised to 2 and then 2 raised to 1. Now this is the small term. Small problem will be when b equals to 1, then we will return a. So since it is a small problem, we will return 2. Now at this level, what it will do, it will multiply 2 into 2, that will be 4, and then it will pass to its parent function. Now this will multiply 4 into 4 and the answer will be 16, that will be returned to this parent function. Now this will do 16 into 16 and it will pass to its parent function. Now this function will do 256 into 256. 16 into 6 is 256 and then it will return to its parent function. Now this function will do 2 raised to 16 into 2 raised to 16 and return its to parent function. This will be 2 raised to 32. Now this term will do 2 raised to 32 into 2 raised to 32. That will be 2 raised to 64 and then it will get returned. So in this way we actually find the power of an element. Now let's take a practical example and see how this is done. Let's take 2, a as 2 and b as 16. So 2 raised to 16 will be 6, 5, 5, 3, 6. So at last we should get this term. Now this will be get divided into 2 raised to 8, then 2 raised to 4, then 2 raised to 2, then 2 raised to 1. Now since this is a small problem, 2 will be returned. Now at this place 2 into 2 will be computed and that is 4 and 4 will be returned. At this place 4 into 4 will be get computed, that is 16 and 16 will be returned. At this place 16 into 16 will get computed, that is 256 and 256 will be returned. At this place 256 into 256 will be get computed and we will get the answer, that is 65536. So in this way we are actually computing the power of an element. Now let's see the pseudocode. Now this is the pseudocode. I have named the function as POE, that is power of an element, and I am passing two parameters A and B. Now we have to define the small problem first, that is if B equals to 1, then we will simply return A, or else we will first find the mid, that is B by 2, and then we will call it recursively, that is POE A comma mid. Mid is getting from this statement, and then we will store the value in variable y. After that, what we will do, we will multiply it by itself, y into y, and store it in variable x, and we will return x. This is the pseudocode. So let's define what is divide, conquer, and combine. This is the small problem. This is the divide. This is conquer, and this is combine. Now this pseudocode is for when B is even. Now let's define what will happen if B is odd. Let's understand by actually taking an example, a raised to 10. Now what we will do, we will divide 2 raised to 5. After that, what we will do, 5 will be get divided by 2, so we are taking the integer, so 2 raised to 2, and then 2 raised to 1. Now this is the small problem, so we will actually return 2. At this place, what this will do, 2 into 2, that will be 4, so 4 will be returned to its parent function 2 raised to 5. Now firstly it will calculate 4 into 4, that will be 16, and then it will check whether B is even or odd. If it is odd, then it will again multiply by 2, that will be 32, and then it will pass to its parent function. Now at this level, 32 into 32 will be get computed, that is 1024, and then it will check whether the B is even or odd. Since it is even, it will not do anything, so we get the answer as 1024. So what should be the manipulation in this pseudocode? Now here we will, this part will be same. Here we will check if B is even or not. If it is, then we will return x, or else we will return x into A. That's it. So this will be the final pseudocode. This will handle even or odd part as well. Today we will analyze the time complexity of power of an element. So firstly we will see what is divide, conquer, and combine, and then we will construct the recurrence relation from this pseudocode, and after that we will analyze the time complexity. So this is a small problem. This is the divide part. This is the conquer part, and this is the combine part. So small problem will take order of 1 time because it contains no loop. Divide will take order of 1 because it is actually dividing, that's it. Conquer will take t of n by 2 because let's say this take t of n time. So conquered part will take t of n by 2, and combined part will also take order of 1 because it is actually multiplication only. Now the recurrence relation to find the time complexity of this given pseudocode will be t of n equals to t of n by 2 plus order of 1 plus order of 1. This time is for divide and this time is for combine. Now we can replace this term with c, therefore t of n equals to t of n by 2 plus c. Now this is a cost for divide and combine only at first level. Let's find the time complexity by using substitution method. For you guys, it's a homework that find the time complexity using master theorem. So let's denote this equation as equation 1. T of n by 2 equals to T of n by 2 square plus C. T of n by 2 square will be T of n by 2 cube plus C. Now this will be second equation and this will be third equation. Now we will substitute the value of T of n by 2 square, that is this, into this part. So it will be T of n by 2 equals to T of n by 2 cube plus C plus C. Similarly, we will substitute this part into this, because T of n by 2, T of n by 2. Now that will be T of n equals to T of n by 2 cube plus C plus C plus C. Now if you do this for k number of times, this will be T of n equals to T of n by 2 raised to k plus k into C. Now we have to eliminate this part, so let's put n by 2 raised to k as 1 because of the termination condition. So the value of k will be log n base 2. Now we will substitute the value of k in this equation. So it will be T of n equals to, the value of this will be 1 plus log 2n log n base 2 into C. Now the dominant term is this one, so the time complexity will be order of log n base 2. So this is the time complexity of this pseudocode, order of log n base 2. Now here is a homework for you, that you have to find the multiplication complexity of this pseudocode. So thank you.